Welcome to the review for Unit 5, Operations with Scientific Notation, right? We learned how to add, subtract, multiply, and divide with scientific notation. So we started with adding. Now adding, I encourage you not to try to use shortcuts, just convert it to regular numbers, 1, 2, 3, 4. If you move it 4 times, there are 3 zeros. That's 84,000. We're adding that to 7 times 10 to the third. 1, 2, 3 moves, 3 zeros, 7,000. 84,000 plus 7,000 is 91,000. That's 9.1, right? Times 10, and we have to 1, 2, 3, 4 times 10 to the fourth. Here we're subtracting, so we're moving it 5 times and getting 5 zeros. 900,000. We're moving this 3 times. We're getting 2 zeros. 6,400. We're subtracting. This one intentionally has a lot of borrowing or regrouping. So we have to do all that. Then you can do 10 minus 4 is 6. 9 minus 6 is 3. And then a 9. And then an 8. And it's 893,600, which is 8.936. times 10 to the 1, 2, 3, 4, 5, right? It's behind the first digit. So adding and subtracting, just make them regular numbers, but then you have to put them back in scientific notation, right? So adding or subtracting, right? You make them regular numbers. Multiplying or dividing, they're shortcuts. Multiplying 4 times 2 is 8, add the exponents. Okay, so 1.4 times 10 to the negative third. So this is a small number. 1, 2, 3. So it's 0.0014. This is move it twice. 0.062. Line up your decimal points, not the side of the number. 4, 3, 6, 0. Decimal straight down. Then you move this now. All right, so we have to move this, right? Behind the first digit, so it's 6.34 times 10 to the negative second power. We're subtracting here. 1, 2, 0.0206 minus 1, 2, 3. So 0.00. I went too fast. 3 moves, 2 zeros, yes. Borrowing. 9810. 0.019 is 1.89 times 10 to the negative second power. Move it twice. All right, so we are finding the total mass of these two asteroids. So one of them is 4.12 times 10 to the 8th. Move it 8 times. I think you're going to get 6 zeros here. So 412 million. 3 times 10 to the 7th. Move it 7 times, you're going to get 7 zeros this time. And we get 30 million. We're finding the total. We're adding those two. 2 plus 0, 1 plus 3. So we get 442 million, which is 4.42 times 10. We get 3, 6, and 2 more times 10 to the 8th kilograms. Now on the test, you will just, I think, unless I ask you, you're typing a number. I think there is one where I ask for the units, but only one. Read the instructions on each problem. Okay, so that's adding or subtracting. Now multiplying, you do not want to make these regular numbers and try to multiply it. And even if you snuck in a calculator, you didn't have a problem with a bunch of these, because it's a cheap calculator. It will give you an error message, all right, which you are not allowed to do anyway, all right, because this is not needing a calculator. 4 times 8 is 32. 4 times 0 is 0, plus 3 is 3. Well, 4 times 1 is 4, right? And we move the decimal twice because of multiplication there, and so this is 4.32 times 10. We're multiplying, so we add those two exponents to the 11th. With small numbers, same thing. You multiply the two numbers. Let's come down here and do that. 2.6 times 3. 3 times 6 is 18. 3 times 2 plus 1 is 7. we get 7.8 times 10. We add the exponents. -1 plus -4 is -5. Scientists detected 4 asteroids with an average mass of that. Find the total. So it's 4 times this average mass. Okay, so we get 4. Oh, let me write it out the long way. So 4 times 6, 24. And 3 times 4, 12. Move the decimal twice. All right, so we get 12.24 times 10 to the 8th. Don't put that on your answer. Why not? Not scientific notation. We need to make it 1.224 times 10. But all right, now you've made this smaller, right? By a factor of 10. So we have to make this one bigger and make it 10 to the 9th, and this is kilograms. Please, decimal points have to go behind the first digit. You never have 12 in an answer. All right, so then we did division. So 8.2 divided by 2, 4. And so you got 4.1 times 10. Now we have to subtract these exponents, right? So it's, right, 3 minus -6, the top one minus the bottom one. You also could just put this on the top and then add. Both ways work, but it's when you're adding, when you're multiplying, you add the exponents. When you're dividing, you subtract, and it's top minus bottom. All right. So this is 4.1 times 10 to the 9th. How many times larger? All right. So the bigger one with the bigger exponent has to go up top. And so 5 divided by 4. 4 goes into 5 once. Decimal up, straight up, 0 down. And so it's 1.25, and then we subtract the exponents, 6 minus 2, 10 to the 4th. Okay. All right, so now I think these are the harder ones that are toward the end of the test. 7 times 4 is 28. 7 times 5 is 35, plus 2 is 37. Move the decimal 1. So we get 37.8 times 10, add the exponents to the 9th. Not allowed to leave it that way. We have to make it 3.78 times 10. All right, we made that smaller, so we make this one bigger, 10 to the 10th. 1.8 divided by 3, right? This is division. And so 3 into 18 goes 6. So we get 0.6, and then we subtract the exponents times 10 to the 7th. That's not scientific notation. So now we're making this side bigger, right? So what do we do over here? Make that side smaller. 6 times 10 to the 6th. All right, we're at practice. All right, we're finding the difference between these 2 grains of sand. All right, which one's bigger? 1.82 is bigger. Okay, so we have 1.82 times 10 to the -2nd and 1.3. They have the same, right, exponent, so you could do a shortcut, but I'm not a fan. But it's 0.0182. Move this twice. 0.013. We subtract 0.0052, which is 5.2 times 10 to the -3rd, and I think these have been grams. Yeah, and if you do the shortcut here, you still have to fix it, because if you do the shortcut, but now you know how to fix the shortcut. Oh, I haven't talked about this. All right, so if you do the shortcut, you get 0.5 times 10 to the -2nd, but you have to fix it, right? So here right, oops, 0.52, and so you still have to make it 5.2 times 10 to the -3rd. So because you had to fix this, the shortcut really wasn't that much shorter. All right, another how many times larger problem. Bigger one up top. All right, so 1.3 goes into 3.9. Not allowed to do that. You have to make that 13. Then you have to make that 39. 13 goes into 39 exactly 3 times. So we get 3 times 10. 11 minus 9 is 2. So that's the answer. But you also, what's 10 times 2? 10 times 2. 10 to the 2nd. Is 10 times 10 is 100. This is 300. So you got, since the answer doesn't have to be in scientific notation, you could say either. All right, so was total weight of that, right? And we want to find the average weight. So you find an average by dividing. So that's what we do. Right? We're finding the ones you multiply, I give you the average and you're finding the total, right? So 1.64, 4 goes into 16 4 times, 4 goes into 4 1. So you get 0.41 times 10 to the negative second. Can't leave it that way. 4.1 times 10. Now we've made this bigger. So we have to make this one smaller, times 10 to the negative third grams. That's the average weight of the 3. Okay, so we collected, we want 5.4 times 10 to the 10th dollars, and there's 2 times 10 to the 6th people. This is not the U.S. All right, people, and we want to know how many dollars per person that is. This is a division problem. All right, so 2 goes into 5.4. So 2 goes, oh no, come on. 2 goes into 5 twice, decimal straight up. 2 goes into 14, 7. All right, so it's 2.7. Subtract the exponents. 11 minus 6 is 5. So it's 2.7 times 10 to the 5th. And these are dollars per person. So in this country, all right, wow, that's a huge number. Oh, this was a 10. That's why. So it's 10 minus 6. Thank you. I was like, that's a lot of taxes. Okay. Because it's 10 to the 4th. You move that 4 times, you get 3 zeros. That's still a lot of taxes. $27,000 per person. Wow. Yep, that's what it comes out to. That's too much. Good luck on the test. Don't take it until you're ready.